Welcome to The Explainer. Today, we're going to demystify a really powerful tool that helps us find the signal hidden in all the noise. It's called regression analysis, and it's kind of the secret sauce for understanding data and even predicting the future. So let's start with a situation you might know all too well. Picture this. Your boss walks up and says, "I need next year's sales forecast by Friday." You've got tons of data, last year's sales, marketing costs, website traffic, but where do you even start to find an answer you can actually stand behind? Well, this right here is what we call the prediction problem. It's a huge challenge in almost every field you can think of. And this is where we get to introduce our hero of the day, a statistical method designed to find clear answers inside really complex data. You see, the real challenge isn't a lack of information. In fact, it's usually the opposite, right? We have too many potential factors or variables. The real question is, how do you sort through all of it to figure out which factors are really driving the results and which ones are just, random noise? Okay, so the tool that helps us answer that question is regression analysis. So let's really dive in and break down what it is and how it works, starting with the very basics. At its heart, regression analysis is really just a way to understand how different things influence each other. It helps us put a number on it, to figure out mathematically how a change in one thing is related to a change in another. So to get started, the first thing you have to do is decide on the one thing you're trying to predict. This is called your dependent variable. Just think of it as the main outcome or the effect. For our example today, let's say we want to predict the number of umbrellas sold. Simple enough. Okay, so next up, we need to think about what factors might actually cause that number to change. These are our independent variables, or our predictors. And if we're trying to predict umbrella sales, a pretty logical independent variable would be, you guessed it, the amount of monthly rainfall. Now here's where it gets really cool. What's so amazing about regression is how it visually transforms all this complicated data into a single clear picture. And it does this by creating something called the line of best fit. Let's actually visualize this for a second. Imagine we plot out our data from the last 2 years onto a chart. Along the bottom, the x-axis, we have rainfall, and up the side, the y-axis, we have umbrella sales. Each little dot on that chart represents 1 month. What you end up with is this big cloud of data points. But here's the thing. Hidden inside that cloud of dots is a trend. And the magic of regression analysis is that it finds and draws the one, single, straight line that best represents that relationship between rainfall and sales. It's the line that slices through the data with the least amount of error possible. And this quote from ablebits.com really nails it. The method is technically called the least squares method, but all that means is that the math behind it calculates the one line where the total distance from every single data point to that line is as tiny as it can possibly be. It literally finds the best fit. So this perfect line is defined by 2 key numbers. First up is the intercept. This is just your starting point. It's the predicted number of umbrella sales if the rainfall was 0. On the chart, it's simply where your prediction line crosses that vertical y-axis. The second part is the slope. This tells you how steep the line is, and this is super important. It tells you the exact rate of change. It answers the question, for every extra inch of rain we get, how many more umbrellas can we realistically expect to sell? So when you put them together, the slope, which we call B, and the intercept, which we call A, you get a simple but unbelievably powerful formula. With this little equation, you can plug in any rainfall amount you want and predict the sales. Let me give you a quick example. A model once found that for every extra hour of training an employee gets, their performance score goes up by an average of 4.3 points. That number, 4.3, that's the slope. It perfectly quantifies the relationship. But how do we know if our prediction is any good? That's where something called R-squared comes in. Think of it as a confidence score from 0 to 1 that tells you how well your line actually fits the data. So an R-squared of, say, 0.91 means that 91% of the changes in our umbrella sales can be explained by rainfall. And that is a really strong model. Okay, so how can you actually do this yourself? You might be thinking this requires some fancy, expensive software. But the good news is you can actually do it in a tool that most of us use every single day, Excel. Believe it or not, you can run a full regression analysis in Excel in just 3 simple steps. First, you just have to enable the free analysis tool pack. After that, you just click a couple buttons, select your data, and bam, Excel does all the heavy math for you. Now, Excel is going to spit out this big summary table that looks, well, it looks pretty intimidating, but here's the secret. You only need to look for a few key numbers. Right here, we can see our r squared is 0.91, nice and strong. And then down at the bottom, we have our coefficients, the intercept, and the one for our variable, rainfall. And with those coefficients, we can build our exact prediction formula. So if the forecast says we're going to get 100 millimeters of rain next month, we just plug it in and we can predict we'll sell about 26 umbrellas. We have officially turned our data into a predictive machine.
So having a formula is great, but what does this really mean for making better decisions out in the real world? Why does any of this really matter?
Well, at the end of the day, regression lets us move past just guessing. It empowers us to confirm if a relationship really exists, to measure exactly how strong it is, and then use that knowledge to make predictions we can actually count on. It's all about finding that clear, actionable signal buried in all the confusing noise. So that's regression analysis. As you can see, it's so much more than a formula. It's a new way of seeing the hidden patterns that shape the world all around us, which really leaves just one question. Now that you know how to do it, what will you predict first?